Hey, welcome to the Explainer. Today we're tackling a really big question. How does a computer actually see? We're going to break down exactly how your phone knows what's in a picture.
I mean, it really does feel like magic, doesn't it? You just type dog into your phone and boom, it somehow finds every single picture of your pup. But it's not magic. It's actually a super powerful kind of AI called a Convolutional Neural Network, or CNN for short.
Okay, so this diagram really gives us the big picture. You can think of a CNN as having two main jobs. First up is what we call feature extraction. This is where the AI is like a detective, you know? It's scanning the image for clues, things like edges, textures, basic shapes. Once it's gathered all that evidence, it moves on to the second part, classification. This is where it takes all those clues and puts them together to make an educated guess, to actually figure out what's in the photo.
All right, let's really dive into that first block, finding features. And let's stick with that detective analogy. At this stage, the AI isn't trying to solve the whole case just yet. Nope, its only job is to gather all the visual evidence it can find.
So the detective's number one tool, that's the convolutional layer. And really, this thing is the heart of the entire operation. Its whole job is to scan the image and hunt for the most basic features imaginable. We're not talking about a dog ear or a nose yet. We're talking about the absolute fundamentals, simple lines, curves, corners, the building blocks of any image.
So, how does it actually do that? Well, the layer uses this tiny grid of numbers called a filter. Think of each filter as a specialist. One filter might be an expert at finding vertical lines. Another might be looking for a specific curve. This little filter slides across the entire image, almost like a magnifying glass. And at every single spot, it does a quick calculation that basically asks, hey, does this little patch of the picture match the pattern I'm looking for? And the answers to that question create something called a feature map, which is just a new image that highlights everywhere that specific feature was found.
Okay, so after all that work creating these super detailed feature maps, the network kinda needs to simplify things. And that's where the pooling layer comes in. Its job is to shrink the feature map, to make it smaller and easier to work with, but, and this is the important part, it has to keep the most important bits of information. It's kind of like taking a really long report and just boiling it down to the main bullet points.
And a really common way to do this is called max pooling. It's actually pretty simple. The layer looks at a small section of the feature map, say a 2x2 square, and it just picks the single biggest number from that square. That's it. By only keeping that maximum value, it's making sure that only the strongest signal, the most obvious feature in that little area, gets passed on. It's a really clever way to get rid of the noise without losing what's important.
And here's the really cool part. This isn't a one-time thing. The network actually stacks these layers one on top of the other. So the first layer finds simple edges. Then the next layer takes those edges and learns to combine them into things like corners and curves. And then the layer after that might combine those to start seeing shapes that look like eyes or noses or mouths. See what's happening? Each layer builds on the one before it, creating this hierarchy of features from the super simple to the really complex. It's this whole layered approach that makes the system so incredibly powerful.
Okay, so our detective has done all the legwork. It's gathered all the clues, from the simplest edges to more complex shapes. Now it's time for block 2, making a prediction. This is where we finally solve the case.
But before it can make that final call, the network has to get all its evidence organized. Right now, all those features we found are stored in these different 2D maps. So to get everything in one place, the network does something called flattening. It basically takes all those maps and just lines up all the numbers into one single super long list. And that list has a name. It's called a vector.
And you can see that happening right here. That whole stack of feature maps gets squashed down into that one long line of numbers. That's our vector. And at this point, it's basically the complete summary of the image. It's like a numerical fingerprint that has every single important clue the AI found. All right, so this vector then gets passed on to the fully connected layer. If the last part was the detective work, this is the grand jury. This layer looks at every single number in that vector, every last piece of evidence, and it learns how to weigh it all. It starts to figure out that, hey, if we have pointy ear features plus wet nose features plus furry texture features, well, all of that together probably means we're looking at a dog.
But the final verdict isn't just a simple yes or no. What the network actually gives us is a list of probabilities for everything it knows how to recognize. So instead of just spitting out the word dog, it'll say something like, okay, I'm 85% sure this is a dog, but there's a 10% chance it's a cat and, maybe a 5% chance it's a squirrel. Whatever gets the highest score, that's its final guess.
Now, this whole process is seriously powerful, but it's not perfect. There's a really common problem that can pop up when you're training these networks. It's a weird kind of problem because it happens when the model actually learns a little too well.
This problem has a name. It's called overfitting, and it happens when the model, instead of learning the general idea of what a dog looks like, it just memorizes the exact training photos it was shown. The student analogy is perfect here. It's like cramming for a test by just memorizing the answer key. You might ace the practice questions, but you're going to fail the real exam because you never actually learned the material.
So, how do you stop a super smart AI from just memorizing the answers? Well, developers came up with a really clever and surprisingly simple solution to force it to learn the concepts instead of just the examples.
It's called a dropout layer, and here's what it does. While the network is training, this layer just randomly switches off some of the neurons. It just tells them to take a break. By doing this, it makes sure that no single neuron becomes the only one who knows about a specific feature. It forces the whole network to learn the information in multiple ways, which makes it way more flexible and a lot better at recognizing photos it's never seen before.
And it's all controlled by one simple number. So a dropout value of, say, 0.2 just means that at every single step of training, 20% of the neurons are randomly told to sit this one out. I love the analogy of a team working on a problem, but some of the members keep randomly leaving for a coffee break. It forces everyone who's left to work harder, to communicate better, and to come up with a more robust solution.
So, there you have it. That's the whole journey. We start with just a grid of pixels, the network finds edges, then it combines those into features, it flattens all of that evidence into one list, and finally, it weighs everything to make a smart, probabilistic guess. It's a total transformation, from just raw data all the way to real understanding.
And this process has completely changed the game. It's the tech behind everything from, finding your dog photos, to powering self-driving cars, and even helping doctors diagnose diseases. Which really leaves us with a huge question for the future, right? Now that we've basically given computers the ability to see, what are the most important things we should ask them to look for next?